Hi, this is Andre, and thanks for checking out Synthesophy. Synthesophy is scientifically integrating the wisdoms of history, based on fact and truth, into our present culture. Let's take a little side trip today. Let's call it Side Trip 1. For this little side trip, question your perception. Recall Chapter 7. Your consciousness and perception of reality that is generated by the 100 billion neurons in your brain is your neural reality. With this in mind, maybe it's a good idea every once in a while to question our perception. The Panzo illusion is a geometrical optical illusion that was first demonstrated by the Italian psychologist Mario Panzo in 1911. He suggested that the human mind judges an object's size based on its background, by its position in a field. He showed this by drawing two identical lines across a pair of converging lines, similar to railroad tracks. Take a look here. Let's ask the question, which is bigger, A or B? Upon first glance, looks like A is probably bigger than B. But in reality, they are both the same length. A is about 5 inches, B is about 5 inches. You can also see that it's the same size by lining them up like this. Why is it that when looking at it, A looks bigger than B? Here your mind perceives depth as a determining factor for size. Its placement in the field impacts your perception of size. Here's a variation of the Panzo illusion, which sounds quite similar to a Ponzi scheme, and they're actually pretty similar. Take a look at these three figures. Which one looks bigger? The one in the back, the head is almost touching the ceiling of the tunnel. The one in front doesn't even reach the first line, not even 1/3 the size of the tunnel. So your brain perceives this fellow in back as taller, as bigger. But in actuality, they are also all about 5 inches tall. What's going on? Here your mind perceives depth as the determining factor for size. It influences your perception of size. The Mueller-Lyer illusion is an optical illusion devised by Franz Karl Mueller-Lyer. He was a German sociologist in 1889. And what he noticed is the line segment with the tails pointing outward appears to be longer than the line segment with the tails pointing inward. It seems pretty obvious. But in actuality, both lines are the same length. They're both about 17 inches long. We can confirm that also by lining up the ends like this. And what you can see is sometimes what you perceive is not actually true. The herring illusion is another optical illusion. And the herring illusion is a geometrical optical illusion and was discovered by the German physiologist Ewald Hering in 1861. He noticed that when two straight and parallel lines, the red lines, are in front of a radial background, like the spokes on a bicycle wheel, the lines appear as if they're bowed outwards in the middle. Does it look like they're bulging out? Seems pretty obvious, doesn't it? Actually, they are both perfectly straight. So what we can see here, sometimes what you perceive is not actually true. Another good illusion is the checker shadow illusion. Notice we have a checkerboard. Notice the checker tile A appears to be darker than checkered tile B. It seems pretty obvious, doesn't it? But when we scroll down, in actuality, we see that they are both the same color. When we look at tiles A and B connected by two rectangles of the same color, we can see that tile A and tile B are the same color. Actually, they're both the same gray color, RGB, red, blue, green color, 120, 120, 120, to be exact. Looking up here, they appear obviously to be two different colors, but in reality, they are the same color. Edward Adelson, a professor of vision science at MIT, created this illusion back in 1995 to demonstrate how our human visual system deals with shadows. When attempting to determine the color of a surface, our brain knows that shadows are misleading and make surfaces look darker than they normally are. We compensate by interpreting shadowy surfaces as being lighter than they really are. So we interpret square B, a light checkerboard tile that is cast in a shadow, as being lighter than square A, which is a dark checkerboard tile not in a shadow. In reality, the shadow has made B just as dark as A. It's a neurological illusion. Sometimes your brain plays tricks on you. A variation of the checker shadow illusion is this horizontal bar illusion. This horizontal bar that seems to gradually move from light gray to dark gray from left to right in the opposite direction of the background. Now, what's actually happening here, if you cover everything but the bar itself, you'll see that it's actually monochrome. It's all one gray color. We just saw lighter on this end, darker on that end. Look at it now. It's all the same color. What we see here is sometimes your brain plays tricks on you. Let's see if we can figure out why that is and how that happens. This is called the simultaneous contrast illusion, similar to the checkerboard shadow illusion. The brain interprets two ends of the bar as being under different lighting and deduces what it thinks the bar's true shattering would be. The brain thinks that the left end of the bar is a light gray object in dim lighting, and the right end looks like a darker object that is well lit. However, as we just saw, the brain is overcompensated in its perception. This is exactly how the brain reacted in the hot and cold water test in the introduction. The brain overcompensated, but with heat back then and there, just as with light here. And that's exactly how the left politically interprets statements from the right, and how the right politically interprets statements from the left. They neurologically overcompensate their differences to the point of generating polarization and animosity. You could say here that the left sees the middle gray as white, and the right sees the middle gray as black. Two polarized views of the same thing. We can see from our visual experiments here that our neurological perception of reality, our neuroreality, can actually be wrong. So we need to question our perceptions of reality and scientifically analyze them, as these scientists did, to make sure our perception of reality is as close as possible to actual reality, i.e., that our perceptions are true. Recall, nature knows only truth.